Thank you. Thank you everybody for having me here. Awesome. So yeah, I'm going to talk a little bit about multi-agent systems. To talk about agency, I'm going to try not to rehash the Stanford philosophy page about agency, because I don't think that's necessarily what we want to talk about. But I want to talk about how agency actually will impact the technologies that we're building. And I'm going to base this off of a lot of experiences that I've had over, say that like the first time I really started thinking about, I guess, agents in general was probably around 2017. But I would argue that we've been dealing with types of agents since maybe the 80s or 90s. I don't know if anybody's used IRC or any of those types of systems. We would have bots. When I worked at Microsoft in the early 2000s, we had MSN Messenger, where there were also bots. They were all really terrible. But I think because of the fact that now with LLMs, the ability to synthesize language in a way that we haven't been able to see before, I think this changes the way that we start to consider how these tools might fit into our work. And so, as you said, I do product ops, specifically portfolio operations for the Copilot team at GitHub. And then I'm also the lead responsible AI champ for GitHub in general. And then, there's a bunch of other things on here, but maybe what I'm going to talk about a bit, I'm not going to talk so much about my time at Google, which was in the core machine learning group, but I will go through a couple different case studies, one of which included my time at Facebook Gravity Labs. So with that, I do want to try to sell you something right now very quickly. I am giving a course right now. This is our first week, and so if you did want to join, you'll be joining about, you'll be able to see the recordings and things like that. But we've already done 2 sessions. It's 3 more weeks after this. If you're interested in learning more about AI design patterns in general, you can get 25% off just because I realize that the first week is already over, but you can still see the recordings. This is where I dive deep into the different case studies that I'm going to talk a little bit about today, and then also give you workshops, and it's mostly focused on how do you have great conversations between the technical and non-technical people, especially for very emerging types of technologies like AI, machine learning, those types of things. So with that, I will end the sales pitch. So the first thing I want to talk about is this case study from 2017, where I was working on a project for a company called Philosophy, which was a boutique design consultancy. And in particular, we were building a bunch of different small kind of prototypes with a lot of really rapid user research for Google and PwC. And the goal there was that PwC wanted to try to go down market and address smaller companies' abilities to use consulting. But they wanted to use less consultants. They wanted to make it easier for consultants to spread their time across many clients. And then Google Drive wanted to sell more seats. And so the partnership between the two of them started to think about how might we actually enable technologies to service in very particular verticals. And so one of the verticals we worked on, this was probably over the course of about 1.5 to 2 years in total. This was a series of projects over a year, usually in say 8 to 12 week sprints, essentially. And field service operations, if you're not familiar with the term, is this idea that if you can't take something and then return it back to the manufacturer to then have it repaired or serviced, that they have to go on site for it. And so that could be like an HVAC system. They can't take this out of the building and send it back, someone has to come here to fix it. In our case, one of our model customers we were looking at was a group called Larson, and what they did was gas station construction and repair, which is actually an awful lot like IT management because everything has an IP address within the gas station now. You can see here that they were taking apart this machine to be able to understand what's going on. There's also mechanical components because of the pumps that are into the tanks below. And I sat in this truck actually for about 2.5 days just watching them do their work, which is called contextual inquiry from the standpoint of user research. And learning kind of how we might be able to actually aid them or help them solve some of the problems that they come across when they're out in the field. We also sat with the dispatchers, which were sitting in an office and trying to figure out how do they intake customer problems and then schedule field techs, coordinating with the warehouse to be able to get the parts, coordinating with senior field techs to be able to understand really what is the real problem here, especially because there was a lot of variance in the skill level of the people that were doing this field tech work. So some of the things that we started to do, and this is part of not really, I guess kind of a playbook for our innovation consulting stuff, was to first map out the problem. And so this is something called Rich Picture, and it's where it comes from something called SAW Systems methodology, which is from about the 80s. If you look up Checkland, that would be the person that took this. This is like post-cybernetics and systems thinking, where systems thinkers were constantly saying, we keep on building these perfect systems on paper, but then something keeps screwing it up, and it's these small squishy things that are people, that are in between the gears of these systems. And so soft systems methodology is about the fact that we're now going to take into account not only the systems themselves, like the machinery or the, in this case, like services or apps or whatever, but we're also going to include the people and the way that they end up actually using technology as intermediation between other people. And so this was really important, I think, because we started to think about not only the fact that each one of these people here is an agent, but there could be other agents that then would take some automated action. And I'll talk a bit about what I mean by like automation versus agentive technology in just a little bit. But this was like kind of the first step towards understanding socio-technical systems as actually multi-agent ones in the first place, at least for me. We also did a lot of prototyping, and so this is an example of where we did a usability study for a particular prototype. And we built, I would say, about a third of the things that we prototyped. This one in particular was a experience where we were trying to understand kind of like, did people understand what was going on, like interpretability? And did they like what was going on or not when they understood it? And this really takes us to the idea that we also need to understand how people perceive the technologies that they work with. And so below the line here, this was all about like where we need to do a better job of the user experience in some way. On the right-hand side was that people understood what was going on, they liked it, and that was usually automations or other things like that that we wanted to do. And we felt like it was validation of our product. And upper left-hand corner was people knew what was going on, but they didn't like it. And at first, I interpreted this as job security concerns, like the machine is going to take my job in some way. After thinking about this over a couple months and years since this particular study, I became to realize that actually the upper right-hand corner are all the bullshit pieces of their work that they don't want to do, that are burdens on them in some way. And the upper left-hand is actually things that they enjoy and find meaning in their work. And so I always use this as an example of where when we talk about what agency is meant to do, is it's meant to automate the bad parts of their job. We still need to allow, this is my making a case to all of you, that when we talk about agentic or agentive technology, that it should be to actually assist human beings in the meaningful work that they need to do. So that's something I just want to always start every one of these conversations about. So, like I said, some of the problems we were trying to solve were things where dispatchers were having a lot of busy work, field service was being very reactive, they had to make return trips all the time because they didn't have the parts that they needed. The warehouse was not ordering way ahead necessarily, they had to put things on the truck the morning of rather than a couple days before, because we're talking about a wide 3-state geographic area. And this was one of the prototypes we built. And what you can see here is that it looks like kind of a regular chat interface or a job kind of history interface. But some of the things that we were, I guess, hypothesizing could become actual machine learning assisted or using agentic technologies were things like, right here, this idea of what needs to happen. There's actually a recommended time frame that uses a bunch of things, including constraint programming for the way we would do scheduling, estimation of how long a particular problem would take to solve, what parts were necessary, what field tech was most appropriate for that. You can see recommended parts here too. But this was I tend to use this as an example of where it's not just about this idea of chatbots, it's about all these other things we need to do when it comes to prediction of what we need to do. But this right here, Patrick, adding a description, Patrick was the personification we chose for the agent in this case. And it was actually a record that everybody on the team would have access to. So that meant the field techs, the dispatchers, the senior field techs, warehouse people, and would add and remove people as appropriate to be able to get the right type of discussion happening. And so this was I think we built a lot of different chatbots, how does the field tech actually find out what is the right part to use or something like that, and that was fine. But we started to really see some benefits in the fact that if we had an agent controlling the conversation to make sure the right person was always involved, that we started to actually discover this idea of multi-agent kind of conversation and communication that was really powerful and effective. And especially if the agent could go off and do all the hard work and then bring back what was actually the recommendation in some way. So that's where I first kind of came across in the work that I was doing around multi-agent. And so maybe this takes us to a book that also came out that year called Agentive Technology, Designing Agentive Technology by Christopher Russell. And he's a principal designer at IBM. This book came out in 2017. And he's seeing like a really big uptick in sales, which is good for him. I'm glad to hear that. But what he really talked about was this way of how when there's such a thing as a technology that can go off and do something and use tools on its own and coordinate with other people or agents in itself, that we need to think about a different way of how, one, we build patterns of interaction, but also what are the kind of the prerequisites for being able to have a technology that will be effective. So I definitely recommend this book. He's probably going to start doing a lot more speaking because of all this agent mania that's happening right now. But it's really, I think it's a good book. But what he really would start to think about and talk about at the time, because there wasn't really a lot of agentive technologies, at least from his perspective, where it would have some type of impact on the world in a very particular way, it was usually physical things like the Nest thermostat. So you consider the Nest thermostat to be agentive. I think we could also include the Roomba. There's other things like that, which were more physical objects than technological ones. And while he would say that this was agentive for a couple key reasons, we would start to then talk about this like spectrum of things between humans and kind of AI or machine learning. And in particular, I think that the other thing we can overlay on top of this is whether this is a tool I consider to be part of what I am, right? It's an extension of my body in some way, versus something that is other from me that I need to interact with to get the right thing done. And so I've generally started to think about this idea of like manual, and I think of these as a kind of almost like macro patterns for stances of technology. But again, manual is something that I do, I know how to use it, I consider it just like an extension of me. It'd be like a hammer, I just know when to use it, I know how to use it. Assistive ends up being that there's some type of back and forth that may happen, and so the most classic version of that would be like a spell checker, where the spell checker could be using lots of different types of technologies, by the way. I'm not necessarily saying that we're just talking about machine learning here. In the case of spell checkers, they use a lot of different things, including just the idea of what is a commonly misspelled version of this word, but also machine learning models to be able to guess that when you're doing touch typing on your iPhone, that this letter is next to this one, and usually you mean this one rather than that one. Agentive gets into this realm of that there still needs to be interaction between the person that is setting the agent off to do the thing that it needs to do, and the agent itself. Whereas automatic, and the way he differentiates this, is that usually the human being never really checks in on it, other than like very particular cases. And so automatic would be an example, like a very classic automatic would be like a cron job that runs all the time. If you have data scientists, they probably have a job that collects data and parses it like once a day or something like that. That's automatic. You try not to actually touch those systems. You want them to just work. Whereas agentive, it's more about this idea that we're talking about a back and forth, we're checking in with each other in some way. So I think that's why this book is really interesting and a good model, I think, to like when we start to talk about agentive technologies. Now, he's also said like there's terminology like agentic technologies, and while he will get into the pedant, like being a pedant about the fact that like one is Greek and one is Latin, by the way, I think he thinks of things as like agentive as an interaction way, whereas agentic is actually this idea that it's going off and doing something on its own. So if you hear that type of terminology, I just like to provide it. He also has this whole loop about like how you can enter this loop or get out of it, and I'm not going to walk through this, but I just think it's something that's interesting to think about is like, what is the way that you need to set something up? How do you let it go? How do you give it feedback? And then how do you disengage it when it's appropriate? So this leads me to a weird question about agency, which is, there's an ongoing discussion inside the AI world about what is alignment between a machine and a human being. And we'll talk about this at the very end, but I want to pose this question to you, is that how much alignment is there in a real agent or not? And I think this is a key question for us to answer when we talk about the philosophical ways that we enable this technology. So I'll leave that there, we'll talk about it at the end. So the next thing is that we also from this work, and this leads into kind of the next case study, is that we are actually networks of agents, as I talked about earlier. And this comes from a bunch of work I did with Facebook Reality Labs on a Portal device. And so this is a graphic that was from an O'Reilly article about computing. But it's about the fact that like because we are actually intermediated by technology, sometimes devices or services, and that is between people in some way, that we need to maybe consider the way we look at this network in a slightly different way. And so that leads me to something that's called actor network theory. And this is something that I think comes from the 80s, where it starts to talk about the idea that there are actants, right? These are people that are, or these are things actually, that are taking action in some way. They are inside of networks that we need to consider the actual quality of the network, how interconnected the network is, all those types of things. We need to think about the fact that for every network edge, there's actually symmetry. So that means that even though something may send something somewhere else, it means that there's also some type of reaction that should be able to come back the other direction. And then finally, there's a translation step, because every actant inside of a system actually ends up having different types of information, different context, and different ways of actually communicating. So if we start to use this, right, like I want to take us now into this idea of the Portal device. And people are not familiar, it was a really awesome device that I worked on for a couple years, where basically it was a home calling device. It was also fitting on your TV, if you want to do that, which I think is an amazing idea. I think it's the biggest screen in your home to be able to call your relatives. It is now canceled, unfortunately, but I still use it every day. And the Portal device, what I worked on there was like a lot around identity. How do people actually change their identities in these things? How do they know which identity is actually applied inside of a communal device, or like a device sitting on the kitchen counter, whose identity is actually on that device right now? But also things like biometric recognition for face and voice, and then voice assistant integration like Alexa, and then Metazone like internal voice assistant. And so what this took me to is, before I get this started, one of the things that we had to think about an awful lot is that there are going to be many people that use this device at the same time. And so what will happen is that two people may come up to this device and actually want to use it at the same time. They may try to use it alternating. And so this is something that I found on the internet that was about this idea of like, how do we actually start to use something like role play to understand the way that people and technologies interact. And I'll just let you watch it first. But it's about a website.
A request for a proposal. I really don't need a proposal. I don't want to waste your time.
The website.
I'll fill out this request for a proposal.
All right. Can I just send you an email or something? Is there an email anywhere?
I'll fill out the request for a proposal.
Okay. All right. Contact person. That's me, right?
Contact person.
My name? I guess that's my name. I mean, how often do people actually fill out this for other people? Usually the person who, okay, anyway. I'll fill out my name. Enough, right? Okay,
so the thing that's funny about this, to me at least, is that it's taking a lot of things that we would usually think of as just like, I'm sitting in front of a computer, filling out a form, and turning it into something that is more about interaction between two agents. And so this was like the beginning of me understanding how we might use these types of things to actually do role play, to not only do prototyping, but also to think about what does it mean. Like one of the things that we had to think about a lot was like privacy implications of data that was shared on shared devices. And so in those cases, right, the shared device could show photos of me on here, or it could show photos of me on someone else's portal that actually their Facebook account is connected to. Or one of my children could call one of my Facebook contacts, even if it was like an ex-partner or something like that. And so we get into really weird places where we already start thinking about something like contextual integrity is another privacy framework in theory. By Nissenbaum that we started to really like leverage in understanding this, but it's all about this idea of people that are sending and receiving information inside of this like actor network theory concept. And so one of the things that we ended up doing, this is actually a fight that I've had in my household where I'll say I want to play one thing, no, not Rolling Stones, I'm not that old. But then my child would want to play something else. And one of the things we were really considering with the like the virtual assistant team inside of Facebook was like, how do we decide these like multi-person use cases in some way? And so what we did is we put together an hour-long kind of role-play session. We had two people play people that were opposing each other in some way. And then we had 4, 5, 6 different strategies that we wanted the Portal device to consider when it came to actually recognizing or understanding these people. And so that could be the way that it actually ends up working most of the time right now is it's the last utterance that the device understood will be used, okay? But it could also be that it understands and separates the two different pieces of audio and says to the second person, please wait, I'm going to address this one and then get to you. There's a couple other things you could do there. What we ended up doing is we ended up having a lot of awkward experiences as 3 people, 1 person playing the device, to be able to understand and prototype what would be valuable from an agentic or an agentive standpoint for this device. And we found out that actually, because of all of the norms inside of every household that are constantly evolving, that we couldn't do a good job of it. And so we decided to then just do the simplest thing. And so, if anything, rather than us going out, working with research to be able to separate different audio streams for different voices, building out an actual prototype, putting it in people's homes, we found very quickly just the weirdness and awkwardness of doing anything other than just like a very standard thing right now. It was actually a thing. It probably would not want to do that. And what should it do instead when it encounters something like that? And so I did this workshop. I created some cool art for it. I didn't create it, I paid someone to create it, but I really love this art. I'm trying to use it as much as possible. But what we would do is we'd do something called animistic design, which came out of Philip Van Allen in Art Center originally. He's now at Delft. But this is this idea that every object has some type of inner spirit, and that it is personified like other people for us to be able to engage with it. And so this comes from a lot of different spiritual traditions, like First Nation people, paganism, Shintoism, where the reason why we do this, and the reason why we personify in general, is because it helps give us a mental model on how to deal with this thing that is not us, that's not a human being. And so animism, at least animistic design, what we did is we created, because I also play role-playing games, so we have character sheets. We created a character sheet for every device in the home. We had every individual, actually, and so this was, we would talk about what are the attributes of a lamp? What would a lamp be like? We would talk about what are the emotions that should be involved, that could be imagined for these devices. We would then, inside of this conference room, there's a bit of performance art where we were trying to imagine a future world where devices were thinking back about the humans and stuff like that to get people in the realm of actually understanding this. And then we role-played it where everybody played a device, some people played humans, and then we started talking about what was a common scenario that we would have to deal with right now, where if someone gets to the door to deliver something, and what does the doorbell want to do in that case? What devices in the home does the doorbell actually communicate with? How does it alert the meat bags that are inside the home? What does it do in those cases? What does it not want to do in those cases? And this gave us a lot of really interesting kind of observations about how these technologies should interact or not interact with each other. And I think what's really valuable about this is that it really tries to take into account not only this kind of actor network theory, the way that there are networks of devices and people, socio-technical systems, but it also tries to get people to start thinking about the fact that we need to be able to understand how to deal with all of the devices and the agents that we're going to be dealing with. And so I am not one to push for full personification of something. I worked for the Miro workshop version of this. So one of the things I started to look at as a provocation is really this idea that because of things like LLMs, and you can start to then build context and prompt to be able to have an LLM act like what the Roomba should act like and communicate with other devices, this starts to get at a real problem with home automation, which is that home automation is usually very brittle. It's usually, I set a rule for Monday, Wednesday, Friday at this time, but it doesn't deal with exceptions like if I walk into a room, does it turn on a light, but not, it shouldn't do that if someone's sleeping there. And so started to just provocate, how do we start to even use all these agents together in a communication, and I'll talk about how this is related to some more modern research, but how do we use this as a way to prototype setting exceptions inside the home, being able to understand why something did something without having to check all the different apps. And now, I don't want to advocate that we should all live inside of the Beauty and the Beast home where, everything is singing at you. I think this gets back to the animistic side of this, which is, I don't expect a lamp to sing at me. I expect it to maybe blink its light, or turn on and off, or increase its intensity, or do something like that, and I expect it to maybe listen to me, but I don't want it to talk back. And so I think these types of models end up being really helpful in the way that we look at the human-computer interaction side of these types of devices and agentic technologies in general. So yeah, and by the way, the person who played the Roomba in the South by Southwest one, they were terrified of the dog poop. And they did want to message the humans to then take care of it for them. So, now we get to today, and we start to think about what are real multi-agent systems. And so GitHub, I would argue, is beginning to be a multi-agent system. I would not say it's there yet. But some of the examples I'll use as like maybe proof for this. One is this idea of, in general, there are people here. There's lots of people here, right? There's people that are working on repos together. They're committing code. They're writing comments. There's issues, etc. There's a huge network that's being created by GitHub through each one of these repos. The next thing is that we start to have these agents that can exist anywhere inside of GitHub. That means Copilot, chat. That means code completion. That means other things that, like all the different things you could imagine are going to be coming in the future where we need to take code and summarize it into natural language. Those are all things that we want to do. And so we start to then have agents that are more like, if you want to take the mysticism thing, it's like fairy sprites that are everywhere you are, that are constantly there to describe something or help you out with something. But I think what I'm really excited about is, maybe just for my own work as well, if people have not checked this out, this is Workspace. And so this is the idea that for people that are, want to actually make a change to an entire repo rather than just one file or one place, you can start to describe what you need to do, have it actually go through the steps, refine it with you, and then commit that as an entire PR to a repo. I think this is really interesting for people like me. I try not to write code anymore, just because I was not the best. I wasn't a great coder, I was an okay coder. But there are people that are way better than me, and actually probably mostly machines. So what I would argue is that in this case, though, like there's a system that we have right now for pure automations, and those are called actions. And so inside those actions, one of the things that I deal with a lot when it comes to the way that human beings work with each other is automation of moving things around, essentially, or tagging things in particular ways, or moving them from one board or copying them into many boards. And so I think we're starting to get in this realm where things that are automations, once you start to embed things like language models, you start to embed other tools, and this is where extensibility is coming out for Copilot as well. We start to actually get to a real multi-agent system. Now there's some real concerns, especially as lead RAI person for this group, I have some real concerns about this, especially when we start to talk about right now it's just usually one person and some agents talking back and forth with each other. But agents are not talking with each other yet. And so that's like a real hard question. How do we start to control and, I guess, limit the harms that could happen based on that fact? It becomes very hard. And I think the problem I have right now with a lot of multi-agent, every post on Medium that's about multi-agents, everything that we read in a lot of the articles or academic papers is they're not real world yet. And I think there's a couple things that really need to be solved before we can get to real world use cases. And I mean this in all kindness, Crew AI is doing some really interesting stuff. They're going to decimate and fill your inboxes with so much crap, marketing crap that you're not going to imagine. But I would say there's real things they need to worry about when it comes to the way that these types of things are implemented. And so there are going to be 4 things that I think about right here. 1 is performance. It's just not quite there yet. 2 is cost. 3 is expectation setting with the people that we're trying to build these things for. And then 4 is this lack of alignment question. So when it comes to performance, the way most people think about what is happening with regards to an LLM or something like that is that there's a prompt, goes into a model, and then it spits out an output. That is actually not the way it works exactly. The way it actually works is that you give a prompt. There are a bunch of heuristics, like screening for celebrity names, or the idea that there's a model called toxicity model that tries to remove toxic language, or violent language, or requests for adult materials. And then, actually, and there's another part here we'll talk about in a second, but then it goes to the LLM. And then when it comes out, it actually looks for toxicity. It looks for things like fairness issues, might try to correct them, or just say it can't make a response. But there's actually, in this case, we're just showing 7 models, but there's lots of models, lots of heuristic programs that are running to be able to do this stuff. And it gets even more complicated when you start to consider the fact that, in our case, we do a lot of things where there's a system prompt, and then there's other prompts that you as a user give, and then maybe eventually there will be prompts that your organization sets or whatever, right? There's lots of things that are being put into this that are many, many layers between this. And once we start to think about this, I do think this is a really interesting paper, by the way, about Socratic models talking to each other. This came out of Google. And I think there's some real value here, even though that the current way we do this is very programmatic. I think the problem is going to be, and this was like a discussion, another paper about like prompt chaining. When you have something like 80% as accuracy for each one of these steps, you get to, yeah, this is a toy example, right? You don't get the accuracy you need out of the system, basically. There are lots of ways to improve this, and I think that's something that we need to work on more, is how do we build more resiliency into the individual nodes. But maybe that takes us into the next step, which is cost. Because when we talk about cost, right, this is another paper that just came out, I think just end of last week, or it was like July 2nd. This is by the AI snake oil people. What's very interesting about this is it talks about actually now using these tools. If we want to keep on, like, because we get 40% accuracy across it, that means we want to run this multi-agent set over and over again until we get something good. It means that it costs a lot of money, basically. And I didn't include the graph, but like, you know, for some of these things, for one of the tasks they used a model, and it cost $130 to actually process with that particular model to get the accuracy rate that they expected. And others were a couple dollars. That's still like way higher than what most people are willing to spend when it comes to doing this type of stuff. So I definitely recommend this. Benchmarking shouldn't happen without cost for these types of elements. That's what I recommend. The next thing is expectation setting. And so I've been thinking a lot about this idea of what was really problematic for like Alexa and voice assistants in general. And the problem is that the reason why most people really just use like known use cases like timers, music, reminders maybe, and maybe something else, is because of the fact that they know that's a use case. It is the intersection between expectations and capabilities. But there's a huge number of unexpected use cases. And this is part of the reason why Amazon is probably shutting down their skills for Alexa, is that people were not discovering them. They couldn't figure that out. But then when you do things like Siri, where people are constantly joking about how Siri would, you know, they'd ask it for something and would just have no idea what they're talking about, the actual expectations were bigger than the capabilities themselves. So this is something I talk about a lot in, like, whenever I try, there's a particular paper called, it's like other people, you want them to go off and do something better than what you could imagine or expect. And so I think we need to start getting used to a little bit more of this idea that we are talking, if we're going to talk about these things as the other, we need to also consider that it may fail in certain ways that we don't expect. And I just want to point to this article. It came out July 3rd. I thought it was really interesting, which is basically Perplexity is saying they're getting sued, or will get sued. I don't know if it's officially sued yet, based on the fact that they're now accessing pages that robots.txt was saying not to access. And the thing that they're claiming, right, is that their technology works because someone requested that page and they assembled and synthesized a page of references to that particular topic. So the question becomes, like, for something which has been a standard for the internet for a very long time, right? Mostly because if a web crawler went and tried to crawl a website, it could cause the website to crash back in the 90s. That's the reason why robots.txt exists, right? Is robots.txt actually just for anything that is mechanized, including agents that are on my behalf specifically? And this starts to then point at a lot of things about power structures inside of how these agents are then created. Is it the agent for the corporation, or is it the agent for me? And these are like really key questions that we need to start to answer and understand. So, you know, I think when we talk about this, like, what we really want is we want a set of agents that will mostly do what we say, but also try to guess what we need. And that is a very hard problem to solve. So maybe this is not an uplifting talk for this group right here, but I'm just saying that these are the problems we probably need to work on next. And they're mostly about problems in the way that agents actually interact with people. So with that, thank you. I really appreciate it. I'm happy to stick around for questions, but yeah, thank you.
I'll be standing right here, so if you have questions, please form a line here so that we're not running around. So yeah, if you have any questions, please come over here.
Yeah, if you disagree with me also, I'd love to hear your piece about it.
Yeah, so let's just do this.
Hi, I have, my name's Patricia Liu. So I was wondering, from your perspective, when you talk about future agents or agents kind of knowing what you want or being in alignment with you, do you think agents should be better or worse, or would be worse than, say, your best friend who's known you for a long time.
I mean, I have another slide that's part of another discussion about like what are machines good for and what are people good for. And I think that there is a real threat that people will fool themselves into thinking that machines can be their best friend, but they cannot be a best friend. Argue that like, I think these systems can potentially do a lot around provocation and helping us improve the way that we are. But I would argue that like, we need to have another human being that cares about us for that type of relationship, and that goes back to Ector network theory and what we can have in that type of network. That's what I would argue.
Sorry, that was not my question.
Oh,
My
sure.
question is, when you talk about future agents, right?
Yeah.
If you go back to the previous slide or what, where you're talking about, okay, they'll find a balance between doing
Yeah.
what we say and guessing what we need. But I don't even know if humans really have that capacity, right? So that's why I'm asking is, do you think so that's
Yeah.
why I brought up the
Yeah, fair
best
enough,
friend
okay.
example, is because even our best friends wouldn't really be able
Yeah.
to do this.
But I would argue that like an Amazon recommendation of what you might like versus what your friend buys you that you didn't know you wanted or even do want, right, is actually a different type of experience. And so that's where I think, you know, there's a possibility with this type of technology that like there's a paper that talked about like where are the limits of data that we can get access to be able to actually train these types of large models, because we were starting to talk about like what is the biggest model we could ever imagine, right? And what that paper doesn't take into account is actually personalized data as much. It takes into account what is posted on the internet or in kind of social group settings, even if it's on, I wouldn't call it like dark web, but you know, like private areas of the internet, essentially. And so that's maybe another couple orders of magnitude, maybe another order of magnitude, maybe a little bit more. But when we start talking about the idea of like being able to take models that are on the edge, that use kind of federated data, do that type of thing, it has access to maybe all of our information, I think it will potentially be able to calculate predictions better for us, but I don't think it will know us necessarily. Right? I want to make that distinction because there have been many studies also about the idea of like sentiment analysis, in the sense that like sentiment analysis using either like tone of voice, actual like just text, tone of voice, and facial expression actually don't do a good job of understanding our internal state, because we actually don't even understand our internal state most of the time. So I just think there's like a lot of things that we need to like make sure, like we should not be doing sentiment analysis, honestly. I don't think it's a good idea to usually use sentiment. And I've gotten this question, when I was at IPsoft, every bank was like, we want to know what the sentiment of this call is. And I was like, to do what? You're still gonna force them down the same process that they have to do, right? Just they're either pissed off or they're not, and that's it, right? Like, so that's what I would just argue, is I think like there is the possibility for getting more informational context, but I think it helps in some ways, but not others. So I realize that's a very it depends type of answer. But I agree with you, right? Humans to human, probably some of the worst things come out of misunderstandings or certainty about other people, but also the randomness of the way that we end up interacting with each other because of that also can cause really great things. And so I think that's the thing that we need to just be more aware of. And I don't know, maybe we just need to be more couched inside these like types of philosophical discussions where we talk about the value of the thing that we're creating in some way. So, sorry, who's next? Oh, okay.
So actually pulling off that same concept you just mentioned, so what truly is the value proposition that we should be looking at here? We've seen a lot of AI technology out there that's been developed leading with the idea that it's going to be an AI technology, and then doubling back on the idea that there's a problem that you can fix with that. So I'm kind of wondering, if you mentioned cost, you mentioned the reliability, you mentioned some of these other difficult factors that are technologically very difficult to solve. And then you're also mentioning that $130 is like...
I mean, that was one really extreme case, but like, yes, dollars at least, right, on the average.
It may be an extreme case, but it's also a situation where it's like, that's maybe like 2 hours of a professional's time, right?
Right.
Worth. So if you can produce more money, or more effort, and
100%.
For the same amount of money.
Yeah.
So I'm wondering kind of where should we be looking at where the actual advantage is of using the technology to solve the problem, as opposed to just what could we come up with and label as an AI solution.
This is the reason why, in everything that I usually talk about when it comes to how we think about products that include these types of technologies in them, is that we need to be able to understand what humans need. And that is as simple as it gets. I realize that people don't like my AI PM talk, because I'm just like, you just have to be a PM, that's all you have to do. And maybe create a shared language with the more technical people that you can have a conversation about trade-offs. That's what you can do, right? And so that's my simple short answer about this. But I think like also we're not always considering things like when we look at like someone like Ethan Mollick and all the research he's doing around like aiding people in different types of jobs, right? Like the way I use these types of systems, like especially like large language models in my day-to-day work, it's like getting provocation back. It's about ideation, but throwing away most of it. It's about like asking it to help me improve something or telling me how to prove something. It's doing all that type of stuff, but it's not like just doing my job. And so I think that's the thing, the realization we're going to come to very quickly is that even though people think that everything can do that, it's not actually going to do that. Yeah, it's so that's what I'm saying is like, it's kind of like when I worked at Kayak, when we were making the change from basically desktop web to mobile as far as traffic. So it was crossing over, and people were like, wow, people are searching so much more on mobile for travel. And it's like, we're going to sell so much more travel. And it's like, no, we sold the same amount of travel. And the reason why is because it just made it more convenient for when I was with like friends, or I got invited to a wedding, or I had to do a business trip. I could just see like how much would it cost me to do this, right? And so I check it a lot. But I also felt really uncomfortable spending over $1,000 on my mobile phone at that point. And so like I think that's the thing that's really interesting is that there is an like adoption of technology and the specific characteristics of the technology. And so that's one workshop that I've been experimenting with, which is like this idea of analogous innovation. And it comes from, there's a paper about like analogous innovation where you, for the problem and the solution you're trying to find, or a solution idea, you pull up characteristics that are not surface level. And then you use that to try to understand what technologies actually do that. And that's where the difference between a hallucination and a piece of creative work actually is a big difference, right? Because if I'm doing creative writing, I want lots of hallucination. If I'm doing something like fact-finding, probably an LLM that is like completely open, not using a knowledge graph or something else to like RAG to do that, right? When I talk about technologies, that's where we start to like define the difference between those use cases. And so I agree with you. I think it can be going the other direction though, by the way. So for like R&D groups that invent a new technology, I think you can start to look at what the characteristics of that technology and where might it be helpful. And so I think there's like a bi-directionalness with that idea of like using analogous innovation and characteristics together. So that's it. Yeah. Sorry, I think were you still next or? Sorry. Here. Oh, okay. Who has, oh, sorry, over there and then over here, okay? Thank you.
So when I think about agents, we think about machines that have agency. And that means that, right?
You're getting into like a really philosophical territory right now.
Exactly, yeah. Exactly, we're going there, but that means that humans have to like give away control. And that is a very natural and very like intrinsic thing of humans who wants to have control every time. So I kind of think about like...
Well, but do we really have control? Do we have agency?
That's another kind of question.
Okay,
Yes.
well, no, yeah, go ahead.
Going to the practical kind of sense, like, I think about like the phase of adoption of this, because I want to give control to machines to clean my house, but I don't want to give necessary control to machines to negotiate for me something where the risks are like really high. So what do you think about like that in terms of adoption for consumer, but also for enterprises in general?
So I think like there's going to be a lot of technology companies that are going to push the frontier of this type of thing, right? Like the fact that if you buy a house right now, you still have to use what's referred to as wet ink to sign off the documentation rather than something like DocuSign, right? Like there's a lot around regulation, regulatory capture, like all these different things are going to be at play for some of these exceptions that we want to make. I think people will try them, right? It's like the idea of the yuck factor. And I think it was like the original Wired editor that talked about this. But it was like the idea, it's like moral repugnance is the technical term, but it's this fact that like we need to get comfortable with these new technologies and the giving up of certain types of kind of understanding of the world. What we're really doing is we're building higher level abstractions. This is something we've done over and over again, right? Like we talk about what computers, like the people computers, used to be. They were people that were working on actual physical spreadsheets. They were calculating things. When the idea of like actual calculators came about, like a physical mechanical calculator, those people became accountants rather than being calculators. And so it was a level abstraction up of the work, but taking over some of the stuff that is that manual work. So I just don't have like a good rubric other than like correcting against errors that people make, especially if they're errors that are not helpful. And what I mean by errors that are not helpful is like another story where a friend, one of his startups was basically, this was way before blockchain, but it was basically where it would do automatic resolution if a company kind of ended up violating a contractual agreement. And the problem with that, though, was that usually when you violate a contract agreement, it's actually a reason to renegotiate rather than pay the full problem that's in that contract. So that's why, like, I think there's like some things that we just don't do yet. But trying to solve for errors that we don't want, trying to aid in increasing the performance of what people do, creating a new abstraction that people can build a deep expertise on. Those are all things that I think we should be doing with agents in some way. And just in general with these technologies. Again, like some of the stuff I showed you were actually like little boxes on a website, not an agent, right? And so I think we need to talk about like patterns as the fact that we're still talking about people using apps or websites or VR or whatever, and that has to fit inside of an interaction pattern as well. So we're not going to be dealing with people that are full like VR, AR avatars in the near term for this type of stuff. So that's what I would argue about that. Yeah, sorry. I think you were right here. Oh, did you? Oh, sorry, back there.
Yeah, thank you. Great talks. There's
thank
a lot of unconventional wisdom and highlight I would like to mention. You mentioned sentiment analysis and predictions.
Yeah.
And that caught my eyes because in the finance and the cost, and you mentioned a no use case, which is these all bring the roadmap or say mind mapping into like how we actually explore some of the use case in. Well, I'm in the finance field.
Yeah, sure.
So
I think I might know. Are you going towards like actually doing sentiment analysis of like SEC filings and stuff like
Right.
that? Yeah.
and the data is like very
Yeah.
scattered.
Yeah, it's very scattered. It's all over the place. I mean, I also just, I guess, have we proven that there is a model that is created, but is it because of the fact that people interpret the model to be that, or is it because that's the reality of the world? And I'd say that finance industry, there's a lot of things that are where, again, like major financial institutions change the market in a lot of ways. So that's maybe my response back to you about like, is sentiment analysis useful? Yeah, it probably is because there's a model for it in some way. But is it because financial institutions are doing that and that then causes the market to change? This Bloomberg GPT. And one of the things is, again, like, does it write things like Bloomberg GPT and make the recommendations like Bloomberg would? And it's because it was trained on all of its data. So it's like a self-selection type of thing that I worry about. Like, now, is there value there still? I probably. Like, I think like being able to automatically write market signals into an actual like Bloomberg-like report, sure, that feels like that's something that it could take on, right? But the idea of like prediction of the future, especially for highly complex and volatile systems, we get into a space that is very hard. And that's why like stock market prediction, usually when it comes to long term, machines don't do it.
What's the most difficult part? Is the high quality data?
It's the fact that the map is the territory. It's that if you wanted to simulate the stock market, you'd have to simulate the world. And so that's why I would argue that. Now, it doesn't mean that qualitative trading or quantitative trading doesn't work, right? Like the idea of you're closest enough so you can see market trends and you can buy very like microcents every tenth of a second or something like that. That doesn't mean you can't do that. But I'm saying if you look at the people that are successful long term, they are not machines. They're people that have long term investment strategies. That's what I would argue. So sorry if that's not the answer you wanted.
That's okay.
Yeah. Any other questions? Or are we out of time?
I think we're kind of out of time.
Okay. Well, thank you very much, everybody.